Hi, everyone. My name is Ryan. I've been working as a software engineer at Google for 7 years, with the last 3 years spent working on the Dataflow UI. And I'm here to talk about the Dataflow Job Builder, which is Dataflow's newest tool for creating Beam jobs. I'm going to kick things off by introducing the Job Builder and Beam YAML and discussing some of the use cases where the Job Builder is a great choice. After that, I'll give a detailed rundown of the sources, transforms, and sinks available in the Job Builder. I'll also cover some of the more advanced use cases the Job Builder serves. The Dataflow Job Builder is a tool for building custom, no-code, and low-code Dataflow jobs from composable steps. It's part of Google's Cloud Dataflow product, which runs batch and streaming data processing jobs built with the Apache Beam SDKs. The Job Builder specifically is built on top of Beam YAML, which is a declarative syntax for describing Beam pipelines by using YAML files. To create jobs with the Job Builder, users fill out a form, which generates a Beam YAML specification for their job. If you're not familiar, Beam YAML is one of the easiest ways to get started using Apache Beam. Its syntax is concise and readable, and it doesn't require writing any code by default. I'll talk more about Beam YAML later, but if you're interested in learning more, then be sure to check out the next Beam College talk, which will cover it in much more depth. The Job Builder is a great tool to consider if you're new to Apache Beam or Dataflow, because it provides structure and validation around the process of creating data processing jobs. Using the Beam SDKs directly can be challenging because, depending on the language, you need to understand Beam's APIs, write code, and manage dependencies before you can run even a basic job. The Job Builder makes it easy to get started running jobs right away, with built-in blueprints and support for many common data processing workflows. For users that are ready to tackle more ambitious tasks, the Job Builder supports more advanced use cases, like nonlinear jobs, error handling, and cross-language Beam transforms. And for users that want to use Beam YAML directly, the Job Builder supports a YAML editor for quickly bootstrapping YAML specifications. To start creating a job with the Job Builder, the first step is to create a source. PubSub, Cloud Storage, BigQuery, and JDBC sources are supported in the form. And any other source from the Beam YAML SDK can be added with the YAML source option. Depending on the type of source selected, the form provides various configuration options. For text files, CSV files, and JSON files in cloud storage, the configuration is as simple as providing the file path. To process sets of files, the Job Builder also supports wildcard characters. All of these file types can be previewed directly in the Job Builder. Preview is also supported when reading from BigQuery. The BigQuery source supports reading a subset of table fields, which can be selected from a dropdown. The Job Builder tries to be schema-aware as much as possible, and to provide both preset options and validation based on the fields in the data. Transforms in the Job Builder make it easy to modify, filter, and combine data. Like with sources, the Job Builder form supports popular use cases directly, but any Beam YAML transform can be used via the YAML transform option. This is the configuration section for the Python filter transform, which is one of the most popular. A Python expression is used to exclude data records from processing. This makes it easy to check for and exclude malformed or erroneous records. The transform also supports routing records to a separate destination when exceptions are thrown. Another popular transform is the Python map fields transform. This transform allows you to add fields, drop fields, and modify fields using Python expressions and functions. Fields can be dropped individually or by default, leaving only the newly added fields. Like with the filter transform, records that cause exceptions in the mapping process can be routed to a separate sink. New fields can be added with Python expressions or functions, which are referred to as callables. In this screenshot, a dependency is specified and imported in the callable. The SQL transform is also quite popular. It can be used to modify and aggregate records, or to join multiple sources, as shown in this simple example. Sinks in the Job Builder are similar to sources, with PubSub, BigQuery, and Cloud Storage files supported in the form, with other options available via the YAML option. Now, as I mentioned earlier, the Job Builder translates selections made in the form into a Beam YAML specification. The YAML can be viewed at any time and exported using the Save YAML button, which opens a dialog containing the YAML. The dialog also allows you to save the YAML as a file in cloud storage and provides a gcloud command to run a corresponding Dataflow job. YAML files can also be loaded back into the job builder from your clipboard or from cloud storage using the Load YAML button in the action bar. The job builder also supports working with YAML directly via the YAML editor toggle button at the top of the form. This button can be clicked at any time to switch between the form and an editor view containing the job's YAML specification. This allows the YAML to be edited directly before launching a job. YAML providers are a feature of Beam YAML that allows you to encapsulate and reuse transforms. In the job builder, the YAML provider section of the form allows you to select YAML provider files in cloud storage. Once a provider is selected, the transforms it defines are parsed and loaded into the job builder and can be inserted into the form with a single click. Providers can encapsulate sets of YAML transforms or transforms from other Beam SDKs like Java and Python. Providers are useful for teams that want to easily package and share transforms for others to reuse. All a user needs is the location where the provider file is stored, and they can load it in the job builder. To get started with the job builder, check out the Blueprints menu, which contains presets for common use cases, as well as certain data processing patterns. Now let's take a look at the job builder live. This is the job builder. We have form sections for sources, transforms, and sinks, and the graph representing the job on the right side. I'm going to open the Blueprints menu at the top, which contains the job builder's preset options. And I'm going to select word count. This is an example job that reads a text file from cloud storage and uses several transforms to count the occurrences of each word before writing the results back to cloud storage. In the source section, I can click the Preview Source Data button to take a look at the source data. This is a copy of Shakespeare's King Lear play. If I open up the first transform, we can see that it's parsing the unstructured lines of text into a word field and a value field. The word field uses a Python callable to parse out individual words from the lines of text. To see the YAML generated by the job builder, I can click the Save YAML button on the right side. If I copy the job's YAML and refresh the page, I can use the Load YAML button to repopulate the form. The YAML editor toggle button also allows me to see the job's YAML and edit it directly if I want to. Once the form is complete, all I need to do is click Run Job at the bottom. For batch jobs, I also have the option of creating a recurring job that runs on a schedule. If you'd like to learn more, check out the job builder yourself in Google's Cloud Console, or take a look at the documentation. The Beam YAML documentation is also a great resource to learn about the many transform options available. That's all I have for you today. Thanks for joining, and I hope you'll check out the Dataflow Job Builder.